Test-driven development, or TDD, is a software development technique where you will first write your unit tests. You have not yet written the necessary code to ensure that the tests will pass, so they will all fail. Once all of the tests are written, you will then write enough functional code so that the tests pass. TDD is popular with agile software developers for the development of application source code, and it is becoming more commonly used among data scientists. Unit testing, and more in general software testing, is an area of software engineering that we encourage you to explore more, as there are many valuable tools, concepts, and strategies that can help the AI enterprise workflow. For the purposes of our demo, we will keep the examples simple, and we will refer to all testing as unit testing. As you can see, in this directory we have two Python files, and a directory called unit tests. The model.py file is a Python module that contains functions to train and predict from a simple model. The runtest.py file is a Python script that runs all of the available unit tests. Here we use the tree command that is periodically rerun with the command watch to monitor the directory for file changes. As we can see, the newly created file appears in the tree above. We will get to the unit test files in just a minute. Let's first take a look at the contents of model.py to provide some context for the test-driven development use case. All of the necessary code to train the model, serialize the model, load the model, as well as make predictions given new inputs are all contained within this file. This file is also notably decoupled from the API, because we want to ensure that it is relatively easy to swap models. The model version and model version note are included here as global variables, but we will not be using them explicitly until we start incorporating log files. We use here the iris dataset that is built into scikit-learn to provide a simple example of classification. At the end of the file, there is an ifname main statement, which is executed when the file itself is run. We see that there is a function to train the model, a function to load the model, and another function to make predictions from the loaded model. The classification report is being shown. The output from the classification report can be suppressed as needed, but for model iteration and model development, it is very useful. Also note that in the tree, the serialized version of the model now appears as a .joblib file. Let's now write some unit tests to test the functions in the file model.py. Specifically, we are using test-driven development to harden the predict function to various inputs, since most of the model code is already present. End-to-end test-driven development is less common than specific use cases like this one in data science because of the reuse of code and templates. The model, like any model, will need a very specific type of input, and this is a common issue with deployed models. First, let's take a look at the unit test directory to get an idea for how it is structured. A directory like this one that contains an init.py file is a Python package. Typically, there are other .py files contained within. When the package is imported, the __init.py is run. This file serves to combine all of our unit tests files into a single test suite that can be executed with a single command. A simple append to the list that is passed to the unittest.testSuite class will add more tests to this suite. This file runs the suite of tests that were defined in the init.py file. Since we only have tests for the model in this example, let's take a look at the file contents. The first thing you might notice is that the functions themselves have the word test and numbers. They must begin with the word test, and optionally they may increment with a number. The number increment ensures that they are run in order. There are times when the tests should be run randomly, but this convention can be useful when the tests build upon one another. To save time, we have created the functions using the command pass as a placeholder for the code that we are about to input. There are two ways to run the unit tests. This runs the entire suite of unit tests, And if there were any other test files like model tests inside of the unit test directory that were included in that suite, they would be run as well. We can run the files individually, and that will run only the tests contained within the model test file, for example. We see that the first test passes. And this is because we serialized the file earlier, and we can see it up in our tree. We may not want to force remove the file before each test, because training can take a long time. Ideally, we would train on a subset of the data, and then we would use a separately named file that could be discarded after the test is run. To show that all of the tests fail before we begin writing our unit tests and writing the appropriate code to go with the unit tests, we will simply remove the file now. The appropriate functions from model.py have been filled in to save some time. Now when we run the unit test, there is only one failure. This is because we have not yet written the code. If you look at the function test3, it passes a list, and the model predict function expects a NumPy array. So let's go into model.py and allow for this possibility. We now see that all the unit tests pass. This has been a very short and simple example of test-driven development. There is so much more. Spend some time in the documentation of the unit test module and looking at other examples. The next time it is appropriate, try writing your tests before developing the code. The benefits are easiest to see when you apply test-driven development to real-world situations.